we got solving and graphing inequalities. As you can see right here, we have our chart of our inequality symbols. These two are for graphing. This means this is not included in the solution. This means the number is included in the solution, and we're going to get that into a second. But I want to take notice of this. When multiplying or dividing by a negative number, remember to flip the inequality symbol. I can't stress that enough. At the end of the video, I'm going to show why that is the case. And for the meantime, I'm going to show the example, and please remember to. Alright, the best part about solving inequalities is you treat it like it's an equation. What do I mean by that? Well, if I have 3x plus 6 is less than 27, I'm going to pretend that this is an equation. I'm just going to bring down my inequality symbol right here. So I'm going to subtract 6 from both sides, and this goes to 0 because 6 minus 6 is 0. Now, what's left over here on the left-hand side? 3x, and what's over here? 21. Now, what's with this 3 we don't want? It's the opposite of multiplication is division, and I'm left with x is less than 7. Right there is my algebraic representation. That says some number that is less than 7. I don't know, 0, -1, -2, -1,000,000. Those are all solutions. What's not a solution to this? 8, 9, 10, 1,000,000,000, numbers that don't work for this inequality. Now if we put it on the number line, here's 7. Now if I use 7, is 7 less than 7? Not true. So we don't use the closed circle, we use the open circle because it's not included. It doesn't work for our solution. And it's all numbers to the left. And that is our, I call picture representation, but that's also our graph. Our graphic representation. Both mean the same thing, it's just represented in two different ways. Alright, in this example, say we have 4x plus 12 is greater than or equal to 2x minus 4. Again, I treat it just like an equation, but notice variables are on both sides. If you're having trouble with the equations with variables on both sides, please see that video. But right now, I'm going to go through this, treat it as the same way. Pretend again, it's an equation. Let's get the variable to one side. I'm going to subtract 4x because anything minus itself is 0. And what's left on this side? 12 is greater than or equal to -2x minus 4. Alright, we got our variable on one side, that's one goal. What's with it we don't want? That pesky little -4. So let's add 4. I'm left with 16 is greater than or equal to -2x. Now this is -2x, -2 times x. So I'm going to divide by -2. What? Divide by negative number. What happens? That's right, you're ahead of me. You got that. You saw that a mile away. You flipped the sign. But don't forget what I do to one side, I do to the other. So I'm left with x on this side because -2 divided by 2 is 1. 1 times x is just x. And 16 divided by 2 is -8. Now, I personally like the variable on the left-hand side. So notice, the bigger portion is pointing to the x, right? So if I put this over here, the bigger portion stays with it. These two mean the exact same thing, it's just flip-flopped. Now let's get I'm going to put the graphic representation over here. So I have -8. Now, greater than or equal to. If I plugged in -8 right here, would it work? So it includes. And it's all numbers bigger than -8. But let's check our answer. What's a nice number bigger than -8 that we could choose? 0. I always try to use 0 because 0 times anything is 0. Watch, let's go to our original. 4 times 0, that's 0, right? Well, what's 2 times 0? That's also 0. So all I'm left with is 12 greater than or equal to -4? It's happy, it's true, it works. So this was solving and graphing inequalities right here. Again, algebraic representation, graphic representation, they mean the same thing. Here's just a quick explanation why we flip the sign when we multiply or divide by a negative number. If I have x is greater than 3, and let me give a little picture representation as well so you guys can see this. Here's 3, open circle, everything to the right, okay? Now, if I multiply both sides by -1, I'm still in balance, right? Because I did what I did to one side, I did to the other. So I'm left with negative x is something to -3. And what I'm going to do is I'm going to put -3 on my number line. Now, let's pick a number that works for x. 5? Sure. 5 is greater than 3. That works, right? Which means x is 5. Let's plug in 5 right here. Well, what's negative times 5? That's -5, which is right here on the number line. Now, in respect to -3, is -5 bigger than -3, greater than -3, or less than -3? Yeah, it's less than. So notice right there, if you think about this, and you can play the video back, think about what's going on right here. This is why, to make it make sense mathematically, the sign has to flip when you multiply or divide by a negative. If you're not getting it right off the bat, it's okay. Just play it back, choose some numbers and be like, oh yeah, I kind of see where it flips, why it flips.